You know, I think an alternative title to this video would have been Robotics is Whatever You Think It Is. We were originally going to go ask a bunch of our friends who are experts in robotics about two questions that we get all the time, which is what is a robot and how do I get started? Now the bad news is I don't think that there's any path through robotics, and we actually couldn't even agree on what a robot is. But the good news is that you don't need a path through robotics, and it doesn't even matter what your definition of is. Let's talk about every flavor of robot.
Maybe I should start these interviews with who are you and where are we?
Forgive me in advance because I don't really know how to do this style of video yet. Luckily my friends were very patient with me, but I didn't prepare them for this at all.
I'm Vivian. Oh, I thought you were gonna ask. And this is my lab, the Future Interfaces Group. My subfield of that is I work on haptics. So haptics are devices that can physically make you feel something.
My name is Ravi. This is the Intelligent Control Lab. The work in our lab is thinking about how you can allow people to collaborate with industrial robots without, becoming unsafe.
My name is Ananya. I work in two labs and I focus on disaster response and planetary exploration.
Hi, I'm Ronald Verghese. This is the ACUS lab.
I work on cooking robots to basically give you a robot that you can use in your home and teach it new tasks.
Man, everyone does such different stuff. That's crazy.
Now show me something cool. That you can show on camera.
So this is a paper I published 2 years ago. This is a haptic device that is on the bottom of a VR headset. So when you put it on, it's aimed at the lower half of your face. It uses a mid-air technology called ultrasound phased array haptics to make you feel things basically on your mouth in VR. So you can feel like drinking from a water fountain or like eating or drinking, you can feel that.
That's crazy.
So.
Phased arrays are actually used in a lot of different places, but very commonly in antenna design. So it's cool because you can use a bunch of small stationary outputs to move like one effective big output. Swapnil used it, and I think his quote was that it made his teeth tingle, which is a really weird experience. I need to ask Vivian if I can use it sometime.
We want to be able to allow robots to collaborate with other agents. So now that's me on the left, and you can see that despite my best efforts, I am unable to pass this hammer off. And actually this gets super bad if I am just a little bit adversarial. I can just push things way outside the training data regime, and then suddenly, even before I've done anything, the other robot is so confused it has no idea what to do. So this is our first step towards this big giant problem of thinking about how we can do safety for this simple goal-reaching task.
So Ravi's research explanation went into some really cool topics that I just feel like I couldn't figure out how to do justice in this video's scope. Maybe I'm gonna go into some Khan Academy mode in the future about all of these things if people are really interested. But if you take a look-see in the description of this video, I'm linking all of these wonderful people's websites and research, and you should go check them out if you're interested in learning some more in-depth details on that.
Where are we going?
We're going to the planetary robotics lab. Or at least we're gonna attempt.
Well, that's the moon tank.
Very important that you have one of those.
Zoe. Neat.
Yeah, she's a lunar rover analog. So just a test bed for planning and mapping and all that stuff.
Where does this thing normally go?
She's been taken out on field tests to the desert because that's a pretty good Earth analog of like other planets. But to test closer to home, we go to Shenley Park. So we test her on Flagstaff Hill.
Cool.
Yeah, I did a lot of cooking experiments, and then I washed all my dishes after having not slept in 36 hours, and I left them all here to dry, and I haven't touched them since. Right now, when we program robots, it requires a lot of time and effort to give them new skills. Let's say I'm giving my robot to my grandmother, who might need to do something that my robot doesn't know how to do. She's a very smart woman, but she does not know computer science. So my goal is to set up a robot that can learn very quickly from her so she can teach it new tasks around her house. So my most recent project, I did a bunch of that and showed off a robot that could learn to cut veggies and peel veggies and stir a pan and clean up after itself. And that would have been possible had I not used a bunch of other people's work and models.
So in the beginning of this video, I think I said that there is no path through robotics. And to be way less dramatic, what I really mean is that there's no one path through robotics. What I want you to understand if you're interested in this field is that any of them will work. And to help convince you of that, I asked each of my friends what their path was to get to where they are. I think you'll notice when you're watching that everyone has a different answer. And everyone ended up fine.
So I'm curious, what was your path? What was like the thing that you first started to pick up on and feel like you were actually doing, not just your like CS classes in college or like not just your mechanical engineering classes?
Basically in high school, I thought I was gonna be a biologist. And my best friend, she ran the high school robotics FRC team. The first time I saw my robot move, it felt like I had created life, I guess like Frankenstein style. It was crazy that something we built out of like wood and metal and like put some current into was moving and driving and picking things up. And that was an amazing feeling that I'd never felt before doing anything else.
I guess I got my start in doing research in robotics in undergrad. So I randomly selected a faculty member that I was like, she does interesting robotics sounding research and I like robots. So I clicked. She connected me with one of her grad students who was working on how can you best hand off objects from a robot to a human. That project was sort of my first dive into robotics research or human-robot interaction. And I think it sort of opened my eyes to the idea that there's a lot of problems that people don't really think about. And I thought that was super cool.
Yeah, I got super lucky. I went into college not knowing anything about robotics really, and wanted to try it out just because I went to undergrad at a place that has a lot of robotics just kind of kicking around. And that is when I learned about the additional major, and it had all of the classes that I wanted to take anyway.
So I actually got started in robotics in high school with first robotics competition. And in first robotics competition, I think the most exciting thing of robots is the mechanical design. And then when I went to college, I actually switched to math, partially because I didn't get into mechanical engineering. So I'd go to lab meeting and I'd sit there being, I think, 17 or 18 years old. And these things were like fascinating. They were all stuff that I got really excited about. And I was like, oh my God, there's so many ways to take these concepts I'm studying that I really like and apply them in cool ways. And I think at the end of the day, that's what gets me excited.
Now, I know it's a little far into the video to ask and then answer this question, but we're finally going to ask all of my friends the question that I love to argue about with them: what is a robot? And I knew going into this video that none of us had the same answer, so that's part of why it's so fun to ask them.
And do you consider this a robot?
No, I would not consider this one to be a robot. There's not any input to the system. It's all like coordinated with graphics, but we don't actually like sense anything or think about anything with this device.
That's actually going to keep coming up over and over again. We talked about the sensing and then the thinking and then the doing. Keep that in mind.
Do you think a vacuum's a robot?
Yes. Have you talked about the question of is a microwave a robot?
Vaguely. We brought it up.
I'm in the camp on microwave is a robot.
Yeah.
I think it depends on the microwave.
Oh.
Yes. So
Okay.
I think if the microwave is doing some of the thinking for you, like if you have all of the options that are like defrost and popcorn and they actually work as intended,
Okay.
it's a robot. But if you're doing all of the thinking, I think it's not a robot.
Do you think a hairdryer is a robot?
A hairdryer. It is more on the side of being a tool than a robot because it doesn't make any decisions.
Hairdryer?
Not a robot.
Not a robot. Is a hairdryer a robot?
That's a good question. The hairdryer. Ooh, this is pushing the edge of what I think a robot is. Its interaction isn't driven by any of its own processing. The person is controlling the hairdryer, so from that perspective, it's more of a tool.
Sorry, Mrinal, I may have to poke fun a little bit here. What is the difference between a hairdryer and a vacuum? Is it just the airflow and that defines what a robot is?
Okay, what about Siri? That's
Siri?
ChatGPT.
Ooh. So Siri loaded onto like a little like screen device thingy that has a face on it, that's a robot. Siri just on your phone, not a robot.
Oh.
I think they are what I would say is an AI agent and not a robot. It's making decisions and searching for things and giving you information, but it's not physically affecting the world.
We know a robot when we see it. And
That's-
the tools.
That's the last definition of a robot, is if it has robot vibes, it's a robot. Whatever I think is a robot, and you can't disagree with me.
I think it's like the hot dog sandwich thing. You know, it's all food. You know it when you see it. And
I do subscribe to the vibes-based classification of is it a robot or not. Yeah, if it has robot vibes, robot.
there we go.
Anyways, enough of that stuff. I think we can all agree that robot is kind of a fuzzy word. If you really need a definition, I think for this channel, I have a personal definition. I don't even think we agree on this amongst ourselves, but my personal definition of what a robot is, which by the way, falls in the XKCD 1000 most common words, a human-made thing that decides how to act based on what it senses. That's my definition. But I really do stand by that your definition just does not matter at all. The skills that you use and the skills that you learn are going to be very interconnected, and those are what's going to matter. To draw yet another analogy to the kitchen, which I love to do on this channel, is anyone really arguing over what the line between baking and cooking is? I really think that it doesn't matter. You know, it's food, it all works out at the end, and you kind of know it when you see it. Similarly, with robotics, whether it falls in embedded systems or, you know, mechanical engineering or electrical engineering or whatever, you're just using the tools available to you to make something that you think is a robot. Okay, that's great and all, but I don't want to just leave you with, oh, everything's fine, go off and do whatever you want, kids, because I know that's really overwhelming. For kind of the final section of this video, I want to share something that I wish that I had when I was learning about robotics. This is Every Flavor of Robots cloud map of robotics. Okay, so Jesse and I are editing right now, and just a heads up, this section is like super dense, but it is absolutely what I wish I knew about robotics. So I'm leaving it in. I believe in you. You can tough it out.
got this.
We'll
You
put
got
some
this.
memes in there. So my intro to robotics was through the lens of a mechanical engineer. I was studying mechanical engineering in undergrad, and we learned about the design of structure and actuator design and applying physics to make sure that your mechanisms work as you want them to. Eventually, I came to realize that there's not only engineering design, but also design in the artistic and functional sense. User interaction itself has two major subfields, like human-robot interaction, which is HRI, and human-computer interaction or interfaces, which is HCI. And I think it's just safe to say that having skills in design, I mean, it's gonna come in handy, you're gonna design stuff. But you also have the other two that I'll call electronic systems and computer science and stuff. I think these two are also really close to what you would pick up in a bachelor's degree, like in electrical engineering or computer engineering, or as a comp sci major. But working in robotics, you could definitely come across projects that make use of PCB design and embedded systems or instrumentation, and knowing how to program in C and C++ and Python is also extremely common. Overall, I think that these three are what my original understanding of robotics was, but then I started getting into control theory and planning as well. Control theory and planning are honestly where you get to the fun stuff, in my opinion. PID controls, optimal controls, kinematics, understanding what stability means in a system. These are all topics that I group into control theory and planning. And when you start to apply those concepts to robots, you're going to run into two more fields. Math, which I'm not going to go over, and state estimation and sensing. Now these are super related because your sensors are going to tell you stuff about the world, and you can use that information to figure out your best guesses for the state of that world. You're going to hear about sensor fusion and SLAM and computer vision and odometry and like every sensor name ever, and it's a big part of robotics. That was a lot. Let's break it up with a few cute cat pictures and then get back into it. And just ignore the fact that 99% of these are probably AI generated because the internet is kind of dying. Alright, that's enough. Back to it. Another big part of robotics, the big kahuna, so to speak, very related to comp sci and computer tools actually, but also a lot of math, is machine learning. There's actually a lot of different types of learning inside this group of topics, like supervised learning and unsupervised learning and deep learning and imitation learning and reinforcement learning, and I guess we'll throw in large language models or something. But for now, let's have a really smooth segue to the last but not least topic that I think deserves a spot at the table, material sciences. This one's controversial, I guess, but I think it's very robotics related. I think most robotics innovation is coming from advances in motor design or material properties or all of electrochemistry that's pushing the boundaries of how we power our robotics. And then even like the nanoscale side of applying physics to control really small things that people might not have considered robots before. And yes, again, super work in progress. Come chat in our Discord if you want to discuss these type of things or help us out in the YouTube comments section, because I'm sure there's a lot more work that we can do on making this concise and clear. And I mentioned that this is what I wish that I knew, 5-10 years ago, heck, even a year ago. But I also asked my friends what they wish that they knew. And honestly, I think their answers were just so thoughtful and gold in terms of advice.
If you could go back in time and tell yourself one thing, what do you wish you knew? Don't go back in time and tell yourself like your favorite chocolate chip cookie recipe that you found, but like...
I failed a couple classes in undergrad, and as someone who was a pretty good student in high school and never failed classes before, that was like a shock to me. Like I was like, I've never had to deal with like failing a class entirely. But I don't know if I would go back and say, hey, don't fail that class, because I think I actually got a lot out of it.
Yeah, I think I learned best by just jumping straight in as well. And that's been true for like, how did I learn ROS? Somebody was like, make this robot like pick something up. I was like, all right, sure, we gotta go to like learn some ROS.
I think when I first started off in taking robotics classes, I was trying to have some level of understanding of every single aspect. And I think that it took a while to get to that point of being like, I can't be the expert at every single aspect of this, and I don't need to be.
I feel like when I was in college, I would wait around until I felt like I knew enough to start a project. And my advice to myself would be, just start the project and you will eventually know enough, even though it's a little painful.
I hope you're inspired to go and learn some robotics. We started this channel because we wanted to help shrink the gap between this passion and the people that are interested in getting involved in it. And if you want full interviews from Vivian and Ravi and Ananya and Mernal, it's all for free on our Patreon. All of our educational resources are always free and will always be free on our Patreon. But if you want to support us so that we can do more like all of these people, we do more videos and interviews and tutorials and resources, general YouTubery, it's very appreciated. Thank y'all. And thank y'all so much for watching. How many times do I gotta say that? And thank you so much for watching. Thank you so much.